This time I'm looking for an equation that has real coefficients, again of a quadratic, but this time instead of being given the vertex and some other points, this time I'm given a 0 and a y-intercept. So I know because this is a quadratic, that means it has degree 2, that it should have 2 zeros. But they only gave me 1. But luckily I know something about complex zeros. When you have a 0 with an imaginary part, its conjugate is also a 0. So I actually have 2 zeros given to me. One of them is you have to infer on your own. I have 2 plus I and 2 minus I are my 2 zeros. And I know I should have 2 because it's quadratic, degree 2. And then I have a y-intercept. The other thing that was given is my y-intercept, which is the point 0, 5. All right, so now I should be able to give my answer in factored form and multiply it out. So when I write a quadratic in factored form, because it's a quadratic, degree 2, I know it should have 2 factors, and then also maybe a leading coefficient. So it would have some leading coefficient, and then my 2 factors, each one is x minus a 0. And I know the zeros, so I can plug those in. So I have y equals some leading coefficient times x minus 2 plus I and x minus 2 minus I. To figure out what that a value is, just like in the last problem, I'm going to take my other point, my piece of given information, the 0, 5, plug in the 0 for x and the 5 for y, and I can solve for a. So I'm plugging in 5 for y and 0 for x. So I'm going to have negative 2 plus I and negative 2 minus I when I replace my x's with zeros. And now the only unknown is a, so I have to solve for a. So I'm going to simplify the right-hand side of this equation. I'm going to FOIL the negative 2 plus I and the negative 2 minus I. Negative 2 times negative 2 is 4, so that's my first. My outer and my inner are the same, except one's negative and one's positive, so those cancel. And then my last will be minus I squared. But you should remember that I squared is negative 1. So this actually says a times 4 minus negative 1. So this that says 5 equals 5a, and a is 1. So my final factored form will look like this, but I now know that a is just a 1. So my equation is going to be y equals x minus 2 plus I and x minus 2 minus I. There's my factored form. And then to come up with a polynomial form, I just multiply these out. We just distribute everything in the first set of parentheses to everything in the second set of parentheses. So I'm going to have y equals, take the x in the first set of parentheses, distribute it to all 3 terms in the second. So I'm going to have x squared minus 2x minus ix. Then move on to the negative 2. Distribute that to each term in the second set of parentheses. So I have minus 2x plus 4 plus ix. Then move on to the I, the third term in the first parentheses, and distribute that to every term in the second parentheses. So I have plus ix minus 2I minus I squared. And then we simplify and combine like terms. So first I'm going to get a bunch of stuff to cancel. I have minus ix and plus ix. I have what did I do? Sorry, I messed up my distributing here. Let's start again. The reason I knew I messed it up is because all my i's should cancel out here, because this is supposed to be a quadratic with real coefficients, it says right here. So I should have no i's left after I multiply. So first, distribute the x. So I have x squared minus 2x minus ix. Then move to the negative 2 and distribute that. So I'm going to have negative 2x plus 4 plus 2i. Then distribute the I. So I have plus ix minus 2i minus I squared. Now I have a bunch of terms that fall out. So my minus ix and my plus ix go away. I have a plus 2i and a minus 2i. Those go away. And my I squared is really a negative 1. So I can cross that out, instead put a negative 1 there. And now just combine like terms. I've got an x squared. Minus 2x and minus 2x is minus 4x. And then I have a plus 4 and a minus, right here, negative 1, which is really plus 1. So this is plus 5.